Welcome to a new episode.
Hello and welcome back to the Copper Connection podcast with me, as always, your host, Chris Bailey. This is our last episode of our Level 2 mini-series, and today we're going to be diving into the last unit, which is plumbing processes. This is the one area, once you suss it out in your head, your Level 2 exam becomes a walk in the park. Because if you can master this, you can give yourself a huge boost towards passing with confidence. This episode we will guide you through the full journey of plumbing processes, from hand tools to power tools, from preparing a site safely to install pipework, fixings, clips and brackets. By the time we reach end, you should feel sharper, calmer and fully exam ready. Take a breath, settle in and imagine you're walking into a workshop, because that's exactly where our journey is going to start. So as I said, imagine you've stepped into a workshop at 8 a.m. It's always the same. You check your tools. So let's walk through them just like the exam expects you to understand them. So hand tools. Pick up a screwdriver. It could be a flathead, a Phillips or a posi driver. The exam love these because they look similar but behave differently. You need to be able to picture these instantly. A key fact, a posi driver has extra smaller lines in the cross. A Phillips is simple cross and a flathead is one straight line. When you're tightening up a screw, the tool must be maintained. The handle should not spin, the tip should not be worn, and you always protect your hands from slipping. Common mistakes students forget: maintenance. The exam wants the basics. Is it clean? Is it secure? Is it damaged? Now imagine you're reaching for a hammer. A claw hammer removes nails. A club hammer works with chisels and heavier work. And whenever you're picking up one, you should automatically check: is the head fixed? Is the handle cracked? Exam tips. Questions often test basic safety, such as what do you check before replacing a blade or using a saw? The correct answer is usually about guards, damage or power supply. Next up, cutting. And the examiners love cutting tools. When you use a pipe slice on copper, you expect a single groove. If it tram lines cut in two grooves, your brain should instantly go to the blade is worn or damaged. This is exactly what examiners want to see. When you grab a hacksaw, remember this one simple truth. The teeth point forward, the cutting happens on the forward stroke. This exact wording has shown up in many exams. Power tools. Imagine you are asked to drill a 100mm hole for a boiler flue. You need a core drill with a core bit and no hammer action. If you use hammer action, the material could crack and the tool isn't designed for that mode with a core bit. Exam tip: whether you see core drill in the exam, think no hammer action. Before you start cutting or drilling, imagine yourself pausing, because safety checks keep you safe and protect the customer's homes. You check the guard on the circular saw, you check the pack test label to make sure it's in date, you check for frayed wires. These simple steps often form the correct multiple choice answer. And don't forget, your pack labelling should be done on site every 3 months. So now let's take a look at threading, bending and crimping, some of the specialist tools they may test you on. Picture you're holding a pipe bender. It might be a hydraulic or a scissor type. Either way, the exam wants you to know what part does what. So the guide or slip supports the pipe, while the former shapes it. A key fact: a hydraulic bender works with high pressure oil. That's a key hazard you must recall. Crimping tools, press fit joints. They need clean jaws and a working power supply if they are battery or mains powered. Blow torches are used for soldering copper. The risk includes burns, fires, gas hazards and the customer's property catching alight. Heat maps exist to protect surfaces when you solder. By now, your mind should feel like the inside of a well-organised toolbox. Now let's have a look at some side preparation. Now imagine you're stepping into a customer's home. You have not touched a single pipe yet, but the exam expects you to know how to protect everything. You lay dust sheets down, protective carpet wrap. You remove fragile or personal items from the work area. You check for existing damage so you can't be blamed for it later. When soldering, you use heat-proof mats to avoid scorching timbers or carpets. Then you look under the floor, and this is where the maths start. Notching timber joists. You need to picture the joist span, which is the distance between supporting walls. The notch must not be too deep or too near the ends. The building regulations part A sets the rules. So when we're looking at notching, we usually say notch an 8, drill a quarter. So a maximum notch depth is 0.125 multiplied by the joist depth. Imagine a 150mm joist. Simply multiply the 150 by 0.125 and you get 18.75mm. That is the deepest notch you're allowed to cut. If you're trying to put 22mm pipe that joist notching, you would have to cut deeper than 18.75mm. This is not allowed. So the correct answer in the exam would be no. You can't notch it deep. Common mistake here, students round incorrectly or forget that these are legal building regulation limits, not just good practice. Drilling timber joists. Drilling also follows specific rules. The position of the holes is all about fractions of the span and the depth of the joist. Holes can start at 0.25 times the span from the support and must stop by 0.4 times the span. They can be drilled on the centre line of the joist, not near the top, not near the bottom. The holes must be at least 3 diameters apart, measured centre to centre, and no hole can be within 100mm of a notch. When the exam asks where to drill, the safest correct answer is the hole must be on the correct line of the joist within the allowed span zone. Chasing walls and floors. Sometimes pipework needs to be sunken into walls and floors. This is called chasing. You must remember the 2 key limit. The maximum horizontal chase depth is 1/6 of a wall's thickness. The maximum vertical chase is 1/3 of the wall's thickness. If the question asks you why you must carefully chase depths, the key reason is cutting too deeply can make the wall structurally unsafe. Fixings. Now picture yourself needing to secure something. Sure, a toilet pan or a guttering bracket. You need to know screw materials. Brass screws are corrosion resistant but more expensive. Steel screws are cheaper but can corrode. Coated screws are general purpose and corrosion resistant. Stainless steel screws are long life and corrosion resistant but more expensive. So, securing a toilet pan where only a few screws are used, you might choose a more corrosive resistant material such as brass or stainless steel. Securing a long run of guttering where many screws are needed, coated steel screws are more economical but still corrosion resistant. Screw head types also matter. Countersunk screws sit flush with the surface. Raised countersunk have a decorated head. Round head screws stands proud and might be used when the screw shows, such as securing copper saddles. Countersunk screws are used when refixing floorboards because the head sinks into the timber and gives you a flush finish, helping to protect the feet and floor coverings. Then come plastic plugs, often called roll plugs. Plumbers mostly use red and brown plugs. Red typically 6mm drill bit and takes smaller gauge screws. Brown typically matches a 7mm drill bit and takes larger screws. A key fact: red plug 6mm drill, brown plug 7mm drill. Make sure you remember that. In plasterboards, special fixings are needed. Toggle fixings are self-drill fixings are for lighter loads. Collapsing cavity fittings are the strongest type and are used to secure heavy items, such as basins or toilets, to plasterboard. If the question asks which plasterboard fixings to use in a newly installed bathroom for heavy sanitary ware, choose the collapsing cavity fittings as they're the strongest option. Okay, so imagine you're running pipework along a wall or ceiling. Interlocking clips are designed for copper and plastic pressure pipework and allow parallel runs with space for insulation. Nylon clips used under floorboards where the pipe is fixed close to the surface and there is no room for full insulations behind the pipe. Copper saddles are used to support copper pipe on skirting boards, again with the pipe almost flush to the surface. Munson rings with back plates are used to support pipework from walls and ceilings. They can be made in brass for copper pipes or cast iron for low carbon steel pipe. The threaded bar allows you to adjust the height. Munson rings with rubber lined are also to reduce noise and vibration transfer through the building structure. Key facts to remember: copper pipe requires brass clips, low carbon steel pipe requires cast iron clips. Never use brass clips on steel pipe or cast iron clips for copper pipe as they can cause corrosion. If a question asks you which clip material to use for a certain pipe, match copper with brass and low carbon with cast iron. Now let's take a look at our clipping distances. Different pipe materials need different clipping spaces. Copper pipe can span further between clips than plastic, and steel can span further again. For 15mm copper pipe, the typical maximum horizontal clip spacing is around 1.2 metres, and vertical is around 1.8 metres. For 22mm copper pipe, these distances increase because of the larger pipe is stiffer. Plastic pressure pipe, such as polybutylene, needs much closer clip spacings because it's more flexible and will sag more easily. Low carbon steel pipe, especially in 1/2 inch and 3/4 inch sizes, can be clipped at greater distances due to rigidity. Common mistake: students often mix up plastic and copper clipping distances. Remember, plastic always needs more frequent support than copper. Now imagine opening a tray of fittings on site. MP fittings are plain copper fittings that need separate solder to be applied with a blowtorch. Soldered ring fittings, sometimes called integral or Yorkshire fittings, have a ring of solder already inside, and press fit fittings are used with a pressing tool to form the joint. Compression fittings use a brass ollie compressed by a nut. Push fit fittings use a grab ring and a rubber O-ring that creates a watertight seal. Exam tip: only compression fittings and push fit fittings are realistically reusable. And feeding soldered ring and press fittings one use only because the joint relies on permanent deformation or solder. Plastic pressure pipe, often polybutylene, must always be used with an insert at the end of the pipe to support it at the joint. The insert is pushed into the pipe before the push fit or compression fitting is installed. The grab ring is the fitting that clamps securely around the insert supported pipe. Low carbon steel pipes come in light, medium and heavy grade. Medium grades, often identified by a blue band, is commonly used for central heating systems. Heavy grades are used for high pressure or steam, while light grades is for specific low demand uses. Threading steel pipe uses either tapered or parallel threads. Tapered threads tighten as they are screwed in, making the joint progressively tighter. Parallel threads remain the same diameter along their length and usually rely on additional seatings or fittings. Key fact: watertight seals on threaded low-carbon steel joints are made with hempen paste, sometimes combined with tape, but hempen paste is the traditional exam answer. When you actually install domestic pipework, you combine everything we've talked about. You plan the run, you consider the notches, holes, chase steps, and building regulations. You choose clips and fixings suitable for the pipe material and the surface. You use the correct tools in the correct way with the appropriate safety checks and maintenance. You prefabricate where possible to save time and improve quality. You sleeve pipes passing through masonry to allow movement and expansion and prevent damage. You use fire-stop materials like collars, where pipes pass through fire-resisting structures to prevent smoke and flame spread between floors or compartments. Every choice you make on site can turn into an exam question. This is exactly why walking through it as a journey makes more sense and makes it easy to remember. Okay, so that brings us to the end of this week's episode and to the end of our Level 2 mini-series. If you've missed any of the last 6 episodes, you can get them from wherever you get your podcasts from. You have just walked through a complete on-site journey for tools, materials, preparation, safety, pipework, fixings and fittings, and calculations. This is exactly how the exam thinks, not as a random list of facts, but as a logical flow of tasks. Now you understand where everything fits, why it matters, and how the exam tries to catch you out. When you read a question about a tool, imagine yourself holding it. When you see a question about a joist, picture the span and run the numbers calmly. When they ask about clipping and screwing, imagine installing the job in a real house. Take confidence from these students who master the Level 2, rarely struggle with the rest of the qualification, because this unit builds your real-world thinking as well as your technical knowledge. You have the knowledge and the mindset to answer the questions calmly and accurately. Keep revising, keep practicing, and remember, every tool you pick up, every screw you drive, every pipe you clip is one more step towards becoming a fully qualified plumbing professional. You can pass this exam, you're capable of mastering this trade, and the Copper Connection podcast is with you every step of the way. I've been Chris Bailey, this has been the Copper Connection podcast, and we will catch you on the next episode.
We'll be back next week. In the meantime, please subscribe and thanks for listening.